Okay. On your scratch paper.
You're gonna let us write.
Okay.
I'll send it to your next time.
No. Okay. Some of you, you should have already turned in your quiz and homework 3. If you didn't, go put them on my desk. Some of you do not understand what we spent several days on. So I have to do 2 things right now. Number 1, I need to make sure you understand it. But number 2, we need a reality check. You're in a math class. We cannot go this slow or we will not finish. So you have to do your homework. You can't take 3-4 days on a quiz. Okay, I understand we had an early release day and that slowed some of us down. But if you didn't finish that quiz, you need to get your crap together. Because we have a AP test that's like a 5-hour test. And we're not going to finish with like I didn't do my... No, you got to get it together. Okay?
5 hours?
Wait, how long?
It's 4 hours.
Oh my god.
But with a break, it's more like 5. Because they give breaks between sections. Okay, we can't...
No, I got it.
It's 6 free responses. Each one has multiple parts. And then you have a 17 part and a 25 part. It's 4 hours-ish. Okay? So I want you to sketch a graph of a function. Yes, right. You can write it on your scratch paper if you want. F of x with a relative max at x equals 2 and relative minima, remember that means plural, at x equals -3 and 6. Do it.
I'm right.
How's your day going?
It's so good.
It's cold out there.
I know. I like the cold. I hate it. Okay, I like when it's cold inside. I hate when it's cold outside.
What? No.
I like when it's cold inside.
I like when it's hot.
I'm a different person.
I like the...
I hate wearing coats,
When it's cold.
rain jackets, umbrellas.
I like jackets.
My hoodies and sweatpants? Yes.
Yeah, that's like my best part about hoodies and jean jackets. I don't like these jackets.
Looking like a whole
I
ass
like-
rug.
Okay, did you do it?
Remember sophomore year, I wore the big jacket the last day of school. I got made fun of so much.
My mama brought me a brand new jacket.
I brought Ashton one of those puffy little marshmallow jackets. He got made fun of so bad. I had to buy him a new one.
They're cool.
No,
I gotta wear
He
them.
had like he's like a 10-year-old, really skinny with big glasses.
that's me.
You know,
So like the guy from the Christmas Story?
I haven't seen that. I know everyone's seen it except me, but I haven't seen it.
I haven't seen it either.
Thank you.
I don't know what you're talking about.
Okay, 2. I want your graph to have a max. I'm gonna do like that to remind me it should be a max. Okay, then at 3 and 6, I want min, so -3, we'll put it here. 6, maybe we'll put it, I don't know, here. Okay, so ready? We're gonna connect the dots. Now, your graph might not look exactly the same as mine. That doesn't matter. Okay, so I'm gonna go down to the min, up to the max. Down to the min, up to the max. Okay, and then actually here, I don't like that that looks like a straight line, so I'm gonna bend it a little bit better. Like that, okay? But my max is here. What? They don't have to be the same, because that's a great question. So remember that a relative minimum doesn't have to be the lowest everywhere. It just has to be the lowest in its own little area. So it's okay that they're different values, they still both count as relative. Now, how would I change the wording if I wanted it to be the lowest? I would say absolute, or what could I say? Global. Okay, so this is a graph of f of x. Are we good with that? Okay, I want you now to graph f prime of x. Okay, so I'm going to help you do it. Okay, so right below that, we're going to do 2 derivative tests. We're going to do a first and a second. This is my f prime derivative test. This is my f double prime. Okay, what is f prime if this is a graph of f of x? The slope, very good. Okay, where do I have a slope change on the graph of f?
2,
2,
3,
3, and 6. Okay, so 3, 2, and 6 are my critical numbers. Now, what type of critical number is 3, a min or a max? So my f graph went from decreasing to increasing. What type is 2? So it changed from uphill to downhill. Okay, then at 6 it's a min, so it changes from downhill to uphill. What then were the signs for f prime? Negative, positive, negative, positive. Okay, so in my graph of f prime, I'm going to draw it right below here. Negative 3 is here, 2 is here, 6 is here. I should have zeros at each of those values. So at negative 3, how does my graph pass through 0? From negative values to positive values, so it should go like this. Now, don't draw a graph, just put negative to plus switch.
So we're not going to...
We're going to do it in a second. Okay, at 2, how do the signs change for f prime?
Positive to bottom.
Plus to negative, positive to bottom. Okay, good. Okay, then at 6, how do they change? Negative to positive, so negative to positive. Okay, now, in order for me to connect my graphs, I need to know where my points of inflection are. So look back at your original graph. I'm going to highlight all of the sections that are concave up. So at the beginning of my graph, is it concave up?
Yes.
Concave up till about when?
Negative, positive.
About like...
I'm going to stop at like negative 1 just to have a whole number. So from here to here, it's concave up. We agree? Okay, then it's concave down, like a frown, until about when? Okay, I'm going to say here. And then it switches back to being concave up, yeah? So the orange sections of the graph are concave up. Then where are my points of inflection? I'm going to put X's on them. I had one here,
One right there,
one here,
and one right there.
and then that's it, right? Because it was up, concave up, down, concave down, up, concave up. So what are my points of inflection that I'll put on the second derivative test? Negative 1, and then if this is 2, that'd be 4. Now, what were the signs for concavity? It was concave up, down, up, down, up. So what were the signs of f double prime? Positive,
Negative.
negative, positive. Okay, now this is very important. Remember that f double prime is the slope of f prime. So how should my slope change for f prime? I'm going to look at the signs. Positive slope, negative slope, positive slope. So I'm going to go positive slope until when? Negative 1. And then what I'm going to do at negative 1? Negative slope until when? 4. And then at 4, how does my slope change? Back to positive, and I need to go back through 6. Okay, now let's look at the connection between the graphs. If this was a graph, label it. This is a graph of f prime. Let's check and make sure that all of our connections are there. If this was your graph, what type of extrema would this be on the original graph? It's a negative to positive change. It's a min, just like on your quiz. Look at the graph. Is there a min at 3? Yes. Okay, now go to 2. What happened at 2? I was supposed to have a max. Do I have a max looking at my graph of f prime? Yes. Okay, then what about here? Min, and then look at your graph. Do you see the connection? I have a min. Okay, now we're going to do the graph of f double prime. This is not tested on the AP test that often, but it is on there sometimes. So go down to f double prime. What is f double prime in relation to f prime? F double prime is the what? The slope. when does my slope change sign on the graph of f prime? Positive until -1, negative until, positive until the end of the graph. Those will become my zeros, my x-intercepts. So what are my x-intercepts where my x's were? -1 and 4. Now, before -1, actually my -1 maybe should be scooched over a little. That looks like where I put my -3. Okay, before -1, what is the sign of f double prime, which is the slope of this graph? It was a positive slope. So it's going to be a positive value up here somewhere. After -1, what happens to my slope? It's negative, which means it's going to be down here. After 4, what happens to my slope? So it's going to be back up here, which means I'm going to have down, up.
So we're just drawing big.
Okay, now, this is another exciting connection. Okay, get ready to be very excited. Look at your first graph. What power would this polynomial be if it has 3 bends? Nope. Fourth. Okay, here's why. The number of curves in your thing is always 1 less than the power. So if this graph was an x4th graph, what would the derivative of that be? A 4x cubed graph. And now look at your graph. Does it look cubic? Yes. Okay, now what would the derivative of an x cubed graph be? A 3x squared graph. Look at your f double prime graph. Does it look like a parabola, like a squared graph? Yes.
So you wouldn't. Okay, no.
Now, technically, yes. We just don't know the exact equation. But you're thinking about if that power is going down each time, the number of bends in f should decrease by 1 when I go to the bends in f prime. And then when I go to the bends of f double prime, it should be even 1 less than that, because when you take a derivative, you're reducing a power. Does that make sense?
No,
Yeah.
I'm confused about the graph of f.
Okay, so I'm graphing for f double prime. That's the slope of this graph. So how is my slope at the beginning?
Going down.
Positive,
Yeah.
which means my graph had to be above the x-axis. Then from here to here, my slope was negative, which means f double prime needs to be below the x-axis.
So wait, we're using a double derivative, right?
Yes, so we're doing the derivative of this
So
graph.
we're using x instead of y.
Yes,
Okay,
yes.
now I'm good. I'm reaching. Man.
Okay, does that help a little bit?
I'm good.
So on your quiz, which graph were you given? The middle one. What were you answering questions about? The original. Did you have the original graph? No. You had this graph, but you were answering questions about what this graph must look like. Does that make sense? Okay. So, move on to your notes for me, please. Yes. Sure. Okay, so how many of you guys have taken physics? Everyone? Okay, regular or AP?
Regular.
On-ramps, how was that? Okay, so our next unit, if you did well in physics, you're gonna do great, hopefully. Okay?
What is this?
So we are gonna start talking about position, velocity, and then eventually acceleration.
Hey, Miss, I'm sorry, but I can't do that.
Yes, you can. Now, here's the good news.
My teacher scarred me for life.
No, I'll unscar you. Okay, we're all about that healing. Okay? That mathematical healing. Okay? So, when you were in physics, did y'all do like vectors and stuff, yeah?
Yeah.
Okay, no vectors in calculus. Okay, so you can do a little silent round of applause in your mind.
My freshman year, I don't think I'm gonna remember.
Okay, the only type of physicsy stuff you're gonna have is what's considered one-dimensional. Okay, this is what that means. One-dimensional means that you will always be either on a horizontal axis or a vertical axis.
Only X and Y plane.
you will never have, so you won't even be in a plane, you'll be on a number line. You'll either be going side to side, or you'll be going up and down. So imagine if you had like a power line and there's a little squirrel. What are his two choices to go? Left or right. He can't go forward and backwards. He can only go one direction or the other. Okay, think about like a bug crawling on a rope. He can only go up the rope or down the rope. No 3D movement at all, not even 2D, only 1D. Left, right, or up, down. Okay? So, that makes this version of that physicsy stuff much easier. Okay? So, first thing, position is usually denoted by x of t or s of t when it's horizontal, and then h of t or y of t if it's vertical. Like that. Now, it is not important for you to have that memorized, but just know that usually when they're using x or s, they're going sideways. When they're using h, that's for height, that's usually up and down, and then y would usually be up and down as well. Okay? For the domain, I want you to think about, if my middle letter here is a t, what is time not allowed to be ever?
Zero.
Negative. It can be 0 if it's at the beginning, but it can't be negative. So, your domain typically will be t greater than or equal to 0. So, time isn't negative, and then let's put a usually in front of that. Every now and then they'll give you negatives, but usually not. Okay, so today should not overwhelm you. Today should be easy. It'll get harder, but today shouldn't be that bad. So first thing I want is initial position. When is initial referring to? At 0. So initial position means the start when time is 0. So I'm going to find the position at 0. So our first example, we're going to have a baseball thrown into the air. We have an equation right here. How will I find x of 0? What will I do? Plug in 0. 0 plus 0 plus 16. What do I get?
16.
So x of 0 is 16. Now, I want to draw your attention to this word up here that is directional. What does directional mean? That it can be plus or minus, and that each of those symbols are associated with a direction. So, in this case, my plus 16 means that it's 16 feet above the ground when I threw the baseball. What if it had come out negative? My thing would be below the ground. That's what directional means. So I would say at time t equals 0, ball is 16 feet above the ground. Does that make sense so far? Okay, next question, part B. When does the ball hit the ground? Okay, well think about, if my ball is on the ground, what should its height be? It's on the ground, the height should be 0. So if I want it on the ground, I'm going to set position equal to 0 and then solve. So let's do that. Take your equation right here. We're going to set it equal to 0. Can you factor when the first number is negative? No, we got to pull it out. So I'll have 0 equals negative 1. Then I'll have t squared minus 6t, and then minus 16. Okay, factor that for me. We need numbers that multiply to 16 and have a difference of minus 6. What should I take?
4 and 8.
Okay, 2 and 8. Which one needs to be minus, though, to get a negative 6 in the middle? Negative on the 8. Good. So I have 0 equals t minus 8, t plus 2. Okay, then what are my 2 times that my ball would have been on the ground? 8 and negative 2. Now, remember what we said at the beginning. Time can't be what?
Negative.
Time can't be negative. So it would have to be 8. Now, let's talk about why the negative 2 was part of the answer. What type of graph is this? It's a quadratic. How does it open if the t squared started off negative?
Zero.
Okay, it started off down. So my graph looks like this, and then where does it hit the x-axis? What two values?
-2.
-2 and 8. But remember, this is a model for a ball being thrown. So do I use this part of the graph if I'm talking about time? No. So scribble that part out lightly. We don't want that part. What other part of the graph doesn't make sense if we're talking about throwing a ball in the air?
After it's 8.
After 8. Very good. So my domain for this graph is going to be 0, less than x, less than 8. So my ball starts at 0 time, and I stop using the model when I get to 8. Because it's not like the ball keeps shooting through the earth, going negative. That doesn't make sense. Now, what is the y-intercept? We already found it.
What's it? 16?
16. Because remember, at 0, my y value was 16. So that's this value right here. Now maybe the guy's standing on a ladder. I don't know how he's already 16 feet in the air, but just pretend.
He jumped high.
Yeah, maybe he jumped.
Vertical.
Yes. Okay, so ready for the connection. The derivative of position is velocity. The derivative of position is velocity. Usually they'll use the notation v of t for velocity. And then at that point you don't have several different letters they pick. Usually they stick with v. Okay, now velocity indicates the direction of the object's movement. Now, what's the connection for a derivative? A derivative in the graph is the slope. So at the beginning, when my slope is positive, which direction was the ball going? Up. When the slope changes to a negative, what was the direction of the ball? Down. So, when my velocity is greater than 0, I'm going in the positive direction, which is up for us. But when velocity is less than 0, that indicates I'm going in the negative direction, which on the y-axis is down. What about when the velocity is 0? Think about it. You throw the baseball up, then it stops, and then it's going down. What, for physicsy people, would you say the ball is at rest? Good job. Look at that. Okay, it is at rest. Okay, because if the velocity is 0, the ball's not moving. So I throw it up, it stops for one tiny instant, then it starts going down. Okay? So, find the ball's velocity at any time t. What do we say velocity is for position? Velocity is the derivative. So, look back up at your equation here. We're going to take the derivative. Okay, regular polynomial, what's the derivative of negative t squared plus 16t, or plus 6t plus 16?
2t, negative 2t.
Plus 6. Okay, so my velocity is the derivative of position. I'll put that here. Derivative of position. Okay, and then how will I find initial velocity now that I have a velocity graph? Plug in 0. Not set equal to, plug in 0. So for initial velocity, I'm finding v of 0. What's it going to be? Negative 2 times 0 is 0, plus 6 is 6. Now I'm going to put a plus on it because remember that indicates a direction. So I would say, it says here, interpret in the context of the problem. At t equals 0, ball thrown up at 6 feet per second. Okay, so that tells me how fast it was thrown and what direction it was thrown up. Okay, next question says find the velocity at 5. How do I find the velocity in the 5th second? Yes, instead of plugging in 0, I'm going to plug in 5. Remember, my derivative is still right here. Good. Negative 2 times 5 is negative 10, plus 6 is negative 4. Now, what does the negative tell me about the ball's direction at 5 seconds? It's going down. How fast? 4 feet per second. So I would say at time t equals 5, ball traveling down at 4 feet per second. Okay, so back to our physicsy people. What about if I asked you for the speed of the ball? What would you change? Yes, velocity, but how do you change it? Speed is always positive. Yeah?
Yeah.
So, the velocity at 5 is -4, but what's the speed at 5? 4. Doesn't matter. So the difference, what a physics teacher would say is, velocity has direction, speed doesn't. You're just wondering, how fast is it going? Nobody cares which way it's going. So, right here, speed is the absolute value of velocity. So you're going to turn velocity positive. And what that does is it removes the direction so that you're only measuring how fast. Okay? So, question E says, find the ball's speed when it hits the ground. When did it hit the ground? We found that earlier. How many seconds? Okay, it hits the ground at 8 seconds. So then what do I need to do? Take 8, plug it into velocity. Now, when I get my answer, how's it going to come out? Positive or negative? It's going to come out negative because which way is the ball going when it hits the ground? Down, but then I'm going to turn it positive. So, I want velocity at 8. Okay, well we've done this before. So it's -2 times 8 plus 6. What's -2 times 8? -16 plus 6 is? -10. That's the velocity. What would the speed be then? The speed would be 10 feet per second. Okay, and we understand the difference. Velocity, you're keeping the sign. Speed, you're like, I don't care which direction, I just want to know how fast. Okay, next thing I want you to do is change interval to first derivative test. Okay, because an interval test could be first or second derivative. I don't want your notes to be confusing. So, remember that a first derivative test tells me if I have a min or a max. So let's do it. So I'm going to take my derivative, which is right here. What is the first step after I take the derivative for a first derivative test? Set it equal to what? So I'd let 0 equal -2t plus 6. What can I take out? -2. What's left over? t minus 3. What's my critical number? Okay, set up your number line. Now, I'm going to put endpoints on my number line. Because my graph doesn't go till infinity. When does my model start? What time?
0.
When does it end? 8. So pick a number bigger than 3. What could you pick? 7. 7 minus 3 is? Positive. Multiply it by a negative? Negative. Other side of 3, what could I pick? 2. 2 minus 3 is? Multiply it by the -2? Positive. Now remember, these are the signs of velocity. What do they tell me about position?
Goes up and down.
They tell me the direction. It went up, then it went down. So velocity tells me also common sense, right? If I throw the ball, I know it goes up and down. So what type of extrema is this? A min or a max? That would have to be a max. Very good.
Yeah.
Okay? So I would say I have a relative max at x or t equals 3 because v of t changes plus to minus. Okay, now what were you going to say? About a minimum?
Yeah. Oh, so what's it called? Would the minimum just be like 0?
Because when it, so your minimum would be 0 because that's when the ball hits the ground and then it can't go lower than
Yeah.
that.
So like anytime minimum. Do we need
Yes,
to write that?
if it's this type of question, then yes. Okay, now, last thing. It asks you to find the max height of the ball. Can you find the max height of the ball? You know it happens at 3. How do you know how high it was at 3?
Plug it in.
Plug in 3 where?
To the equation.
To the original. Yeah? For t. So if I want to know the max height, then I'm going to find x of 3. I'm going to plug 3 into the original. Okay? So let's do that. So original equation is up here at the top. Should be a negative 3 squared plus 6 times 3 plus 16. So negative 3 squared plus 6 times 3 plus 16. Okay, look at your numbers. What does this first one come out to?
9.
Positive or negative 9?
Positive.
Careful. Negative. Was the negative squared?
No.
That's tricky. Negative 9 plus 18 plus 16. What's negative 9 and 18 together? 9, and 9 plus the 16 is 25. So I would say the max height or position is 25 feet above the ground. Make sense? So all of the first derivative stuff that we've been doing, as long as you know how to do it, you're just applying it. Okay, and it's very similar to what we were doing before.
Too much. Too much.
No. Okay, turn the page.
Wait, give me good.
Okay?
Just calm down. You're going too fast.
Breathe, miss.
Dang.
It's so hot. Are y'all hot?
Yes, we're dying. This is hot. This is sweating me right here.
I know, me
I can't even eat my
too.
Pop-Tart.
You can't even eat your Pop-Tart because you're so hot? That doesn't even make sense. Okay, maybe remove the phone and don't try to be eating a Pop-Tart, taking notes, and playing Slither.io or whatever you're
I'm
doing
checking
online.
my email.
No? Got it? Good? Good on this? Okay, next one.
Jenny.
Okay, look at it. Next one. Okay, which particle or which axis is our particle moving along for number 2? Still the y-axis. 0 to 6. And then it says its position is cubic. Now question, how often do cubics change direction? Twice. So in my head, I already know this isn't like an up and down I'm throwing a ball anymore. So how do I find velocity?
Check them out.
Okay, focus. How do you find velocity if you have position?
You can just do that.
Derivative. What's the derivative of this guy?
3
squared minus 12 t minus 9.
Okay, next I want the particle to be at rest. What should its velocity be if it's at rest? V of t equal to 0.
Yeah.
What can I take out of that polynomial? 3.
Oh, no, wait.
So I'd have t squared. 12 divided by 3 is a 4t. 9 divided by 3 is a 3. And what will multiply to 3 and add to negative 4?
Negative.
Good. T minus 1, t minus 3. Which means my particle is at rest at what two values?
Positive 1 and positive 3.
Okay, 1 and 3. Next, I want to know when my particle is traveling up, when it's traveling down. That means I need to do a first derivative test. So I'm going to set it up here. I'm going to apply endpoints because how long am I using this model? Only when to when?
1, 3. 0 and 6.
0 and 6. And then my critical numbers are 1 and 3. Okay, let's pick a number bigger than 3, but it has to be smaller than 6. 4. Did you say 2?
Wait, you said smaller than 3.
Said bigger than
It's okay. Okay, 4. We picked 4.
I was thinking about
Huh?
By the T on the second one?
That's a 1.
No, go over.
That's a minus. Yep. Okay, so bigger than 3, we pick 4. What's 4 minus 3? Positive. 4 minus 1? Multiply 2 positives with a 3, still positive. Okay, Ebenezer, this is your moment. Tell me a number between 1 and 3. 2 minus 1 is positive, 2 minus 3 is negative. Times them together.
Negative.
Smaller than 1. Question. Can I pick 0?
Yes.
No.
Yes. Was it a critical number? No. Then I'm allowed to pick it. Now, if it's an endpoint, doesn't matter. But it can't be a critical number. So 0 is good. 0 minus 1 is negative. 0 minus 3 is negative. Multiply two negatives.
Positive.
Positive. So which direction did my little thingy start going, my particle? It was going up, down, up. Because remember, we're on the y-axis. So my particle is traveling up from 0 to 1, 3 to 6, because v of t greater than 0. When would my particle be traveling down on what interval? Between 1 and 3.
So, does that follow a pattern? Like, could you always...
No. Because remember, for any time you have a double root, you won't have a sign change.
You said why 1, 3?
Okay? I'm sorry?
You said 1 and 3?
1 to 3, because that's where my line test is negative.
I thought you said 1 and 3. I'm sure.
Okay. Then from there, I want to find the maximum position. Did I have a max in my chart?
1.
Okay, 1. Did I have a min in my chart for part F? 3. Now, question. Usually, for a graph, they'll tell you absolute max or absolute min. For these questions, if they give you an interval, they mean absolute. They might not say it. If they give you an interval, they are referring to the absolute max and absolute min. Which means I need to do a chart. Okay, Ebenezer, you know it from lunch. What things go in a candidate's chart?
0.
0 and?
6.
Those are my endpoints. What other two things?
They can go 1 and 3.
1 and 3.
Yeah.
Where do I plug in to a candidate's chart? The original. Okay, so for a derivative test, I plug into the derivative, but for a candidate's chart, I have to go back to the original. Okay, and then ain't nobody got time for that, so I'm just gonna type it.
Yeah.
Now 0 you can do by hand.
5, 6,
Plug in 0, what do you get?
5, 6,
0 minus 0 plus 0 plus 3.
5,
3. Okay, so plug in 1. So it's x up to the 3 minus 6x2 plus 9x plus 3. Chart. Okay, at 1, write down the value is 7. At 3, the value is still 3. And then at 6, the value is
Why can't
57.
we use the calculator? Life would be so much easier.
Okay, so what is the maximum position?
6.
Okay, max position is 57. Where does it occur at? T equals 6 seconds. What is the absolute minimum position? Minimum position is 3. It occurs at T equals what two values? 0 and 3 seconds. Okay, and then from there we're going to take a break. We'll finish the rest of it.
Thank you. Thank you so much.
Oh wait, and I promised you a little cookie.
Miss Hunter.
I'm going to just give it to you.